Hello all, welcome to today's webinar provided by Ultra Forensic Technology and presented by Andy Boyle. My name is Michel Paradis, Senior Product Manager, and I will be your host. In previous webinars, as you can see on the screen, we introduced the quantum 3D microscope as well as the scientific foundation for its quantitative analysis component based on 3D measurements. And we also presented a benchmark study comparing the effectiveness of using the quantum 3D microscope relative to using a conventional comparison microscope by working a case scenario involving test-fired bullets from multiple firearms. But in this fourth webinar, we are looking at how to acquire and compare damaged bullets using quantum 3D microscope. Understandably, the ability to examine damaged, deformed, and fragmented bullets can be important for casework, and so it is as well when we're using 3D microscopy. For those of you who may not be familiar with the GoToWebinar platform, I want to show you a few tips. You can click on the orange arrow to collapse the control panel so that it doesn't hide parts of the presentation, and you can click it again to make the control panel reappear. There's a full screen button to maximize the viewing area of the presentation. This can be especially useful to better see images and detailed information. And remember that you can zoom the display in and out with the GoToWebinar controls at the top. And also your mouse wheel, it's more convenient, especially in some parts of the presentation where application screens may have very small font or very small text. If you have questions, please type them in the questions area of the control panel so that the staff can receive your questions. And we may answer during the webinar to you textually, or if Andy can answer them live, or especially at the end where we reserve time for questions at the end of the presentation. But please type your questions as you think of them. We expect this presentation to last about 45 minutes to an hour. So I hope you enjoy it. So our presenter, Andy Boyle, is a forensic solutions specialist at Ultra Forensic Technology, where he has held multiple positions since 1994. Yes, I tried to do the math, and that's about 28 years, right? So including him being an IBIS instructor, firearm subject matter expert for the research team, and in the last 11 years, one of Andy's roles has been to act as the liaison for the Interpol Ballistic Information Network, working in collaboration with Interpol. Andy has traveled the world promoting the benefits of IBIS and the Interpol network to forensic firearm experts and government officials. Andy currently works in the marketing department, and he's responsible for trials and demonstrations of IBIS products and of the quantum 3D microscope that we're using today. Andy's experience with bullets of all shapes and sizes makes him an ideal presenter for today's topic. So with this, I'm heading it off to Andy, and enjoy the presentation. Well, maybe we're having technical difficulties trying to unmute Andy. Please stand by. There you go, Andy. I think you should be speaking now.
This can only go better for me from here.
Yeah.
All right. Thank you very much, Michel.
Sorry about that, everyone. Bye-bye.
All right. Let's jump right into it. Today we're going to be covering 3 chapters, essentially. We're going to start with the mounting process for mounting fragments, damaged bullets. And then we're going to get into the acquisition itself of the exact same fragments that we are mounting in the first part. And then ultimately we'll close with comparisons using the quantum 3D microscope, both the comparison microscope aspects of it as well as the quantitative analysis. So for the mounting process, we have a diverse set of stubs that are supplied with the quantum 3D microscope. And using these stubs in combination with a type of mounting wax like sticky wax, we can adapt to just about any sort of shape there needs to. And if you look at the stubs themselves here, we have 2 that are numbered 1 and 2 that are numbered 2. Each of these sets are identical to each other. Number 1 stubs are essentially for large caliber bullets, like 45 auto, 40 Smith & Wesson. Number 2 would be for medium, like 9mm parabellum, 38 special, 380 auto, even 32 or 7.65 millimeter. And other ones are used for other types, but the one you're going to see the most in action in this webinar is stub number 7 in the back here. He has the longer nose there, which I'm actually going to be using the wax on the side of that nose to work with the fragments themselves. And while we have a nice image here too, let me just call your attention to the indentation here. I call this the dash. This is an indentation on the side of the stub that only appears on one of the 3 edges that the triangular base shape of the stub has. So that dash there is going to come into play quite a bit during the mounting process for damaged and fragmented bullets. And for the samples I'm going to be showing, I have a series of videos now. The first 2 here are from 9mm parabellum bullets that were fired through a Glock pistol with an aftermarket barrel that had conventional rifling. And the first sample we actually see over here, this one is a fragment that only has 1 land engraved area, LEA or Lee as we call them. So there's 1 Lee on this fragment. And so let's go and see how we would take on that scenario. So I'm just going to pause this for a second here. There is the dash I mentioned earlier. So that is that single indentation on the side of the stub. The fragment's in my hand, and ultimately I'm going to be using some wax to place that on the side of the nose of the stub here, and then the fragment is going to get placed into that wax. What you want to do beforehand, though, is get familiar with what is on that surface. And so as you're cleaning the surface, typically with acetone and the cotton swab, get yourself familiar with what is taking place on the side of that jacketing fragment. And in this case, I know there is a single land engraved area that I can acquire. And so the region I intend to traverse here during the acquisition is going to be from just before that top shoulder to just after the bottom shoulder, the driving shoulder, trailing shoulder. I want to cover that distance in the region of my acquisition. And that becomes important because the midpoint of that region, which is essentially the middle of that land engraved area in this scenario, I want to bisect that with an imaginary line from that dash. I want that to cut straight through the midpoint of the region I intend to acquire. The reason is that when this stub is mounted onto the rotation shaft of the Bullet Trax acquisition unit, by bisecting that region through the midpoint, that means that whatever rotation is going to take place during the acquisition is going to be a balanced amount of rotation. It's going to be a predictable amount of rotation as well. And anytime I can take a step to make the transition across a deformed surface act more predictably, I'm going to use that to my advantage. So an imaginary line should be cut through the midpoint of the region. And also another thing about that dash is that when the stub is aligned to be placed onto the bullet rotation shaft of the acquisition unit, the alignment of that is always pointing straight up at 12 o'clock. And so if I get my fragment, and especially the area I'm concerned about within the fragment, if that is in line with what is going to be pointing straight up at 12 o'clock, well, that means that all I need to do is maneuver that underneath the camera, and I should be looking at the exact area that I'm concerned with for this particular acquisition. It takes a lot of the guesswork out of the process afterwards. So let's watch this in action here. Fragment itself is coming up. Let's get the wax mounted onto the side of the nose of the stub in line with the dash. That now gets placed in there. And now the softness of the wax, the malleability of the wax, allows me to twist the base so that it's a very square edge to it. It allows me to get it flat as well, so that the light shining straight down is going to reflect straight back up. And now that particular fragment is mounted and ready to be entered into the quantum system. Second example here now is another fragment. This one has 3 land engraved areas. However, damage and deformation has made that area more or less flat across its length. So let's take a look at this one now. There's number 2 sitting on the table itself, lining up the wax with the dash, and now this gets placed inside. And so the midpoint of the region that I intend to transition across during this acquisition, the midpoint is essentially right through the middle of land impression number 2. And that's him mounted on, ready to be acquired. So once you have a plan of attack and you know what it is you wish to achieve, you can get to that quite quickly. I think both of those videos have been 25 seconds or less in length at this stage. So it comes with experience, but overall, once you understand what it is you're trying to present to the system, how you want to present it, it becomes a pretty straightforward process to line those areas up within the wax on the stub itself. For this final one, for the demonstration here of mounting the fragment, it's another 9mm parabellum jacketing from a Walther P88 pistol, and this one has 3 land engraved areas as well, but it still has the curved aspect to its surface there. So there is some deformation. It's no longer perfectly cylindrical like you'd expect with a test fire, but there is still curvature present. And let's see that one in action as well. There's the fragment, there's the stub. Go around, locate the dash itself. Fragment is placed in the wax, and now in the softness of the wax, I'm going to twist the base to get it as square as possible. I'm going to play with the tilt of the fragment as well to try to get it as flat as possible. And as long as I have a clear view looking straight down at it myself, then the camera should have a clear view of it as well once it's in the machine and ready to be acquired. Now, in case you haven't seen any previous webinars, this is just an example of how easy it is to mount up a test fire. So those are 3 fragments. Each one was pretty much 25 seconds or less, I believe. And the test fire process here, when we're dealing with test fires, we actually go about it a little differently, but it's not difficult at all, as you'll see. So I'll just pause this for a second here. This is called the Bullet Mounting Jig, and this is supplied with the Quantum 3D microscope. And of course, there's the stub on the side with wax inside the nose of the stub. And if you've worked with brass tracks before, our cartridge case product with IBIS, you've seen this clamp before. This is what we use to center cartridge cases before they're entered into the brass track system. And we've taken advantage of how that works and applied it to bullets essentially. So these 2 pincers here are going to get squeezed together. That is going to open up the clamp on the inside here where you've got 3 rubber contact points that are going to widen out and allow me to place the base of the bullet, base down, nose up in the center here. And as the clamp is released, the 3 contact points are going to automatically center the bullet underneath the shaft here. At that point, the stub is going to get mounted onto the shaft as well, and then it's going to get pressed where the nose of the stub with all that wax is going to get pressed into the nose of the bullet. Bullet is mounted and centered. Stub is placed in the shaft. That is pressed into the nose of the stub, of the nose of the bullet rather. And you can give this a twist now and see with the backdrop there that there is minimal to no wobble, and that is ready to go. That was about 25 seconds as well, I believe. So the process for test fires, jacketed test fires especially, if it was a lead, softer surface, I wouldn't use that. I would actually freehand it. But the mounting for jacketed test fires goes quite easily. And each one of these fragments, once you know what you're looking for and how to present it, that process goes quite easily as well. And so with the actual fragments mounted, we will put them into the machine and do an acquisition of each one of these surfaces here. On the right-hand side now, we have the Bullet Tracks acquisition unit, which is also used for the Quantum system. So it's the exact same hardware for both Bullet Tracks in the IBIS family, as well as the Quantum 3D microscope. The data entry process is next to identical. Over here now, there's that dash pointing straight up and our straight down view of the base of number 1, number 2, number 3. Let's go ahead and click on that first one and see the acquisition in progress. So if you have not seen Quantum before, this is an empty workspace at this point. I've created a workspace. to add my exhibits into it. However, there's nothing in it just yet. Of course, you can see it's empty. And so the mouse on screen here is about to go up and add a new item to this workspace. And so as it clicks on that button, we'll see a drop-down menu appear. And the 4 choices we have now, 3 of them are for bullets, one with conventional rifling, polygonal rifling, or unrifled. And you also have an option for an item, which is anything you wish to do 3D microscopy on that is not a bullet. And so for the sake of today's webinar, the selection is always going to be conventional rifling here as I press play and have it begin. So this opens up the acquisition window. And now in the acquisition window here, it's very similar to the Bullet Tracks acquisition window. And the black rectangle here now is where the image of the bullet is going to be captured. Right now, we are not looking at the bullet, though. We don't know where the bullet actually is. And so to help us find it, we're going to turn on 2 pilot cameras by clicking on this button over here. And so when that is actuated, we have 2 cameras show their display, one from the left side, one from the right side, and you have 2 new views of what's inside the acquisition unit at this time. The green square here is showing you the area that the photo box here is currently looking at. And so the mouse on screen is just appearing inside the lower window here. It's going to come up and it's going to click on the base of the fragment right near the tail of the fragment here. It's going to do the same thing over here, and then the mouse is going to come over to the crosshair button right next to the pilot camera button. So I'm identifying where I wish for the bullet to move to, and then it moves to that area underneath the camera. So I quickly found the base of the bullet. It's adjusting the focus now, and I can see what appears to be the top shoulder where I've got the land impression filling up the lower portion of the photo box there. I rename it, and I call this a region acquisition. And now I have the tools available to me to find the center, rotate around the surface here to get comfortable with what's taking place. And while I'm rotating, I want to see what effect rotation has on the way the light is reflecting on the surface. Because when the apex point of the surface, the tippy top of that surface is directly underneath the camera and the lighting, it's going to reflect at its strongest. So I want to find the strongest reflection in the area where I wish to begin, and then I'll set that as my starting point. And as I do set that as a starting point, it is going to do a test scan to adjust the perpendicularity to the shape of the bullet. If it's looking down here now and it sees that that shape it now recognizes is not perfectly perpendicular, it will make an adjustment for the sake of the quality of the light reflection. Now I'm going to do the same process towards the base of the bullet, where I want to end the acquisition. And you can see here the tear away of the fragment where the rest of the jacketing was torn away. So I want to end right where the bottom shoulder is. It's going to do a test scan and now validate the perpendicularity of where I wish to end the acquisition. And now it knows where to begin, and it's accepting as well where to end. And I'm going to be able to start the acquisition in the lower corner. So that whole process was about 2 minutes to do the setup for that fragment. And what we can do now is I'm going to jump forward slightly here just for the sake of speed. The acquisition's begun. This is something that's new here. If you saw the acquiring images blackness there, we no longer show a live view during the process where the light is flashing there. There's about 75, I believe, LEDs inside the system, each LED shining individually to illuminate the surface of the bullet as it's being recorded. And so once all of those images have been captured, they're compiled together, and then they're stitched together here to make the overall mosaic of the surface grow. And during this process, while the image is growing here, there is a 50% overlap of all the information in this photo box here from one photo to the next photo. The previous photo and the following photo have 50% common information between them to ensure that the stitching of the surface is accurate to the true surface of the bullet. So here we are, we're almost done here. Let's jump ahead a little bit. At this stage, it's completed the transition from top to bottom here, from where I set to start to where I set to end. And now it's going to open up the validation screen here. And it got a bit confused with how many really rough areas it saw on the surface. Where it sees a rough transition and height change, it places an anchor line down for you. There were too many on that one because there are a lot of exaggeratedly rough areas. So I just got rid of all of them, and I placed one down near the top shoulder, another one near the bottom shoulder, and I'm taking the opportunity now to get the angle of the striae to be accurate to the surface. The view you see on the left-hand side here is the surface view. What you see on the right-hand side is the same information, however, it's still got the original shape of the bullet surface. So you have the true shape view here, and you have the always top-down surface view over here. And you can use those to complement each other and help you understand exactly where those anchor lines should be set. And then with that done, that is that acquisition completed. We'll go ahead and finish that video. So that is that first fragment acquired. Let's take a look at the second one now that had 3 land engraved areas on a more flattened out surface, or at least what appeared to be a more flattened out surface. Let's have a closer look. So let's jump ahead just a little bit here. So we started the acquisition. I'm telling it where I want the bullet to be positioned underneath the camera. It jumps that area into the center point underneath the camera, focusing on the surface. And so I should be right around the midpoint of my region right now. I'm renaming this one Frag 1. I'm going to call this a region acquisition. And now from this point that I'm currently looking at, because of how I mounted the exhibit, I know that my first land impression is somewhere up here out of sight, and my third land impression is below me out of sight down there. So I went to the top of the first one, and now I'm transitioning quickly to the bottom of the third one. And at this point, I want to make sure that the tail edge of the bullet is always inside this green line. Now that I'm comfortable with that, I am going to actually set this as my starting point at the top, as a start point to the recording. And with that begun, it's going to validate the perpendicularity of where I wish to start the acquisition. Let me jump this ahead just a little bit. Now I'm at the base. I'm going to focus on the base itself. And I'm going to align this how I see as it should be set for the end position for the acquisition. It's going to validate the perpendicularity. And this is interesting here. This looks like I'm about to acquire maybe 360 degrees here around the surface. It's going to correct the perpendicularity and actually shrink that down quite a bit. It still looks like from this view that I'm actually acquiring almost the entire circumference, but what in fact is about to happen is from where I set the start, it is going to need to rotate backwards in order to maintain perpendicularity to the tail of the bullet from the start point to the end point. And that is because this surface is in fact damaged and deformed to the point where it actually is no longer anywhere near cylindrical. It's in fact got a reverse curve to it that we'll see closely in more detail at the validation screen. So the acquisition is in progress now. This part here is all automated. The fact that it is a more flattened out surface is no trouble for the machine because it is using something called advanced repositioning mode, and that uses dynamic surface tracking throughout the acquisition to always ensure that that perpendicularity that it maintained when I set the start and set the end, it is applying that each step of the way throughout the acquisition, one step at a time. And so it never loses that perpendicularity throughout the process, and it maintains the ideal alignment for the scan, and it tracks over whatever that shape might be all by itself. You just tell it where to begin, where to end, and it will figure out how to transition that part. We're about halfway through now. First one's done. Second one, we've got all the way down to the bottom shoulder here. There's a third land impression to cover. Let's jump ahead in the video again. Good marks in that groove impression, and we're starting the final land impression here. 1, 2, and 3 are being tracked. We're right towards the tail end now. Let's jump ahead again. And I jumped a little too far that time. So here is the surface that was just scanned. We're seeing the actual original shape to it, and you can see the bends that were happening in the metal on that surface there. Quite a dramatic twist from where we began over here to where it ended over here. This is all just a little extra step right now for the sake of seeing what that shape looked like. But now we can align this up for a more or less top-down view to help complement what I'm seeing over here, and that will help me set those anchor lines accurately, just like we saw in the first recording. Here I need to add one. When you want to change the anchor line angle, you can grab the circle on either side here and it will pivot off of the opposite circle to let you adjust the angle as much as you need to make it accurate to the striae that's left on the surface. And when you're dealing with a deformed surface like this, where the impact has caused the metal to stretch and bend, it's normal that the angle that may be set accurate to your top shoulder could be different than the angle that is still accurately set at your bottom shoulder. You may end up with a fan pattern. You may end up with different angles at your driving shoulder and trailing shoulder because of the impact that took place. This is where it gets interesting. Here is getting a closer look at the tail end of this acquisition, where you can see that exaggerated reverse curve that this actually had, but the system had no trouble maintaining the perpendicularity throughout that to get the quality scan of the information that was on that surface. These are things that Quantum and IBIS do all on their own. So with the anchor lines validated, that is the second fragment acquired. Let's close this window here. So number 1 is in, number 2 is in, despite the warped bends in the metal. Number 3 still has curvature to it, but it is no longer the original cylindrical curvature from where it left the barrel. It's actually had some impact, and we'll see what effect that has ultimately as we acquire this guy. Find the base of the bullet, go to the base, and now from here, I know I'm looking at land impression number 2. 1 is somewhere up here, 3 is somewhere down here, but I know exactly where I need to transition to work the surface of this acquisition. Let's jump around here for the sake of speed. Let's find that top shoulder. All right, so there's the top shoulder here. Focus on that. That is the close to where I want to begin the acquisition. If we look here, it gets very deformed and damaged just beyond this. There's nothing left of value in that groove impression, so we'll concentrate on getting that land impression acquired properly. Double click on the image to have it do an autofocus, and then we'll hit the next button to set that once it makes sure that it's perfectly perpendicular at that start position. I'm going to go and find the end position. The focus goes away very quickly here because of the deformity to it. It doesn't maintain a nice even focus the way you'd expect with a cylindrical shape. So throughout here, we can regain the focus as we need to. That was the end of number 2. Here's the beginning of number 3. And so beginning here, I'm just going to set my bottom somewhere around this area here and record everything between those 2 regions. There's that bottom shoulder. Play with a little bit of rotation to see what effect that has on the light reflection. And once I'm satisfied with that, I will click on the Finish button, and then the system will automatically apply the perpendicularity algorithms to it and set that as the end position. So tell it where to begin, tell it where to end, and it figures out the transition in between all by itself using advanced repositioning mode. So let's jump ahead a bit here for the acquisition itself. It's been moving along. The focus went away right away when I transitioned from my start point to the midpoint, but here, going one step at a time with perfect focus for each photo, the transition, the focus never jumps that far out of focus in one step. And so throughout this acquisition, one step at a time, it maintains that focus, maintains that lighting all by itself, and keeps the quality of the scan ideal for its needs. That automation is critical as well when it comes down to doing comparisons between other users. Maybe you have multiple people doing their acquisitions on the system, or you want to share acquisitions between two different sites. The fact that the automation here is making all of those choices as far as what the lighting should be, how the focus should be, all those choices are done by the system, and that maintains that consistency from one to the next to the next. So we're almost at the halfway point here. Let's jump ahead a little bit more. 1 is done, 2 is done, 3 is in progress here. There's the bottom edge of 3. We're almost at the end of it. Let's jump ahead some more. Oops, a little too far. Wrapping up the acquisition now, so it'll go to the validation screen in a couple seconds here. So it transitioned all the way across. The base was always inside that green line. Everything was ideal for that acquisition. Quick glimpse at the workspace there. We can see our progress. Fragment 1 was acquired, Fragment 2 was acquired, Fragment 3 is being validated right now. And this is the same process as before, so we've seen this already. The light right now on the shape here, there's a virtual side light shining down, and it is actually casting a shadow. I have it angled so that it casts a shadow down the ramp of the shoulder here, where it transitions from the high groove engraved area to the low land engraved area. I know that the anchor line needs to go right underneath that shadow. But because of the way the light is angled, the raising slope here, where it goes from the low land engraved area to the high groove engraved area, is actually reflecting the light. So here at the top shoulder, or the top shoulder here, it goes underneath the shadow. Here it's placed, for the bottom shoulder, it's placed just above the reflection. Move on to the next one, follow the same steps. This line is going to get corrected to go just underneath that shadow. This one, the angle is going to get corrected, and it's going to be placed just above that white line. And there's the third of 3 land engraved areas. Bring that up underneath. Go play with the angle a bit, get a good view of it. Once again, adjust the anchor line angle, get it underneath the dark shadow for the top shoulder, and place it right where the light is above, right where the light reflects for the bottom shoulder. And those are the 3 fragment acquisitions completed at that time. So that's the acquisition process for fragmented surfaces there. Get them underneath the camera, go to the beginning area of the region that you intend to acquire. It will make it perpendicular. Go to the end position, it'll make that perpendicular. And then during the acquisition, it will maintain that perpendicularity all by itself, whatever the shape is that it has to transition across. So with those acquisitions completed, let's take a look now at the Quantum 3D microscope. This is the main screen that you see when you first open the application. And so from this screen, you would typically go to either create a new workspace or open a workspace you've already worked with. This is what we want to do here, but I can do it a little quicker because it's a recent workspace. The 10 most recent workspaces that have been accessed are available in a quick pick list down here. So I can go ahead and click on that. and access the workspace itself, where I can see fragment 1, fragment 2, fragment 3, and then I also acquired 2 test fires that were simple wraparound acquisitions, test fire 1 and test fire 2. So Quantum at its core is a 3D comparison microscope. And if you want to do that type of work and quickly select an exhibit as a reference exhibit, the first one you select is always going to be on the left. The next one you select will end up on the right. And so I can do a quick comparison right out of the gate here between test fire 1 and fragment 1 and go to the comparison viewer here. In my view now, I have the entire surface unwrapped flat here of the reference exhibit, and I have the test exhibit beside it here, which was just that one little fragment. What's between these 2 pink lines here, this area is what I'm seeing a close-up of in the viewing portion of the screen, the comparison portion of the screen. And so let me go over here, and I'm going to turn on the tools for the reference exhibit. And while I have these tools accessed, everywhere that you see a padlock here, where the padlock is locked, it means that what is applied to one exhibit will be immediately applied to the other. That includes over here as well, where the reference is locked, the test is unlocked. That means that when I click on the reference image, I can move them both together, whereas when I click on the test, just the test moves by itself. That becomes very fast and easy to navigate now when you're doing your comparison work. If we go ahead and zoom in a little bit, my mouse doesn't have to move too far away from that hairline here, the separation line between the two. I'm just dancing on either side, where I can do big movements on the reference side and then fine-tune movements on the test side. Now, looking at these 2 images, there is a bit of cloudiness to the view right now, and that's because I have the depth grayscale view applied, and I also have 0 3D rendering given to it as well. So when you have the raw depth grayscale view, you have the raw 3D essentially that Quantum is doing all of its calculations off of. If I try to play with this tool here, which is the virtual sidelight, as I move this tool around, while there is 0 3D rendering available, it is having no effect on the surface as yet. And that is my preference as a starting point to look at the image. I like to see them with the raw depth grayscale view, because that makes big bold features appear as big black lines or white lines, and it helps me hone in on what is some strong areas of agreement between the 2 items being compared. Once I want to start doing a more in-depth comparison, that is when I will add 3D rendering to the surface. Let's zoom in one more step here. Now, the 3D rendering has a tool here where if I click on this V and hold the button down, I can play with this slider left and right. When I do that, I tend to hold the button down, but then my eyes are going to be looking here. I'm going to be looking at the actual images. And as I work that slider back and forth, I'm going to add as much as I think I need based on what I'm seeing. I don't personally care about the number itself, 68 in this case. I'm not worried about the value. I'm just working with that tool. I'm giving it some, I'm taking some away until I find a balance where I like the actual amount that is applied to it and it's pleasing to my eye. Your choice might be different than my choice, but that's what's nice about this, is that everyone has a chance to set this to a way that they personally want to see it. And that includes the light angle here, where we have dynamic real-time light adjustments you can work with to get the overlap and agreement visible to your eyes in the best way possible that you want to see. And so with this setup now, we can see that the fragment here, the damaged surface, no longer has a uniform width here across the length of that land impression. When the metal surface was bent and twisted from impact, it in fact changed the dimensions of that land engraved area. We have a tool here called Stretch, and I'm going to go to control the test exhibit here. Test number 1, I'm now using the test tool here, and let me just close this. with test number 1, I can play with the stretch here, and if you look at the image on screen, I can give it 1, 2, maybe 3 clicks here to undo the compression that took place from the impact. And so you have a chance to temporarily repair deformations that took place from impact, like what happened with this fragment. Ultimately, if you go back, the value of 0 means no stretch applied, and that goes right back to exactly how it was on the surface as it was imaged. And so that could be a default set point. But in this case, for the sake of the comparison, I want to see what 3% of stretch does for this one, and it helps me to recognize that agreement between the two items. There's another view that you can work with here as well. We're currently working a comparison off of the surface pair. If I want to, I can change this to that shape view as well. So we can do a comparison between these two items with their original shapes applied. And so if I move these guys in the 3D spectrum here, I can see test fire 1 here has its original cylindrical shape, which is what you'd expect with a test fire. However, fragment 1 is almost flattened out. There's a bit of curvature still to it, a bit of a twist as well to that metal. But we can see each of these with their original shapes here. To facilitate the actual comparison, though, between these two that were acquired at different heights with different shapes to them, we can right-click on the better of the two samples. In this case, the actual test fire is over here on the left. I can apply clone shape to that surface and temporarily repair that damage from the fragment. And that makes it lined up better for a visual comparison while doing the shape view. I can bring this tool out over here. Let me just pull this one down a little bit. And I can play with my side light in this comparison view as well as I could with the other view. And it's just another way of giving you a different perspective of the comparison between these two items. Let's zoom in a bit here, play with the tilt and the angle. See, there's some interesting stuff that was taking place in the groove engraved area as well as that land engraved area, especially the one above it. But that is just getting you familiar with what is available between these two items, whether it's from the surface view that where everything is flattened out, or with the original shapes applied, to just give you a better sense of what the relationship is here. So those are some different tools available to you during the comparison. Lastly here, for this particular one, when I want to, let's just hit best match again to realign these. When I'm happy with the progress I've made in my comparison here, I can, well, let me show you another tool actually first. Let's go to the profile lines here. Right now, if I turn this on, I can make that yellow hairline in the center a profile line that is going to read the surface topography on the green side for the reference, on the red side for the test, and it's going to display the true topography of the exact areas on either bullet that yellow line is touching. And that is a real-time information that you'll get feedback on here. Let me zoom in a bit, and let's bring these guys closer to the line itself to get a better view here. Let's unlock him as well. And at this stage now, the dotted green line and red line here, these can be moved for the sake of orientation. I can move this guy out to the bottom shoulder, move him to the top shoulder, and that is telling me exactly where the top and bottom shoulders reside here. If I want to hone in on a smaller subset of stria here, I can bring this up and just see from here to here is exactly from here to here. And so that reaction is going to be live here as you move them along. What is interesting about this as well is when I do movement here with that side light, I am changing the human eye's experience here with the comparison. Some of the stria on the surface here may disappear, reappear, depending on how that light angle is interacting. If we look at the profile meter here, the true profile shape of that surface is not affected whatsoever by how that light dances across the screen. the human eye's experience is, and that's where every examiner can personalize this angled view to how they want to see it. But when it comes down to how the system is working, if I go back to this 3D rendering tool here, bring it all the way back down to 0 for that raw depth grayscale view, everything it sees as far as that topography goes, it sees with pixel point precision in this image, because every pixel has a shade of gray in this grayscale view that is relevant to that topography. And so here, the computer is establishing this base image of 3D during the acquisition. And the automation of that process is meaning that it is consistent every time that it reads this surface. So you have the consistent foundation here from the 3D acquisition for the calculations to be based off with our algorithms, while you also have the personalization that the human eye wants, where every examiner can apply their training and their expertise to get this to be the view that they want to see, to be confident in the conclusion that they're going to draw. One last thing I want to show now is a way to take a snapshot, or a screenshot in this case. If I take a screenshot here, I can name this what I'd like. Let's call it screenshot 1. And here I can say this is LEA 4 to LEA 1. And I can say that profile lines are active. Whoops, let's try this in English. So profile lines are active. This is Lee 1 to Lee 4. And I can do a screenshot of that. Screenshot 1 is the title that was given. The notes that I just wrote are available here. If I want to change those, I can do some live adjustments as I see fit as well. If I highlight a different one, I can see information for testfire 2. If I go back to that screenshot, my notes are back because they were pertinent to that particular comparison. So here, that comparison is still active, it's still live, but if I needed to close this and discontinue my work for the day, let's say, and at this point I only have the base image of Quantum open, the main screen, I can go back and double click on that screenshot anytime I like. Maybe I finish work on a Friday, I come back in on a Monday morning. Not only is everything how I set it, including the stretch that was applied, all of that is set here in front of me, but I can also continue my work from that area and turn off the profile lines, let's say. I can bring this across and do more comparison work. Let's say I want to take a look at what was happening in this groove impression up here. So it's not just a snapshot of your comparison, it's also a progress saver, essentially, that you can go back to at any point that you wish to throughout the process of your comparison work. So that was simply me picking testfire 1, comparing it to fragment 1. If I wanted to as well, I could apply the quantitative analysis to this set, because all of these items were acquired as conventionally rifled bullets. And so fragment 1, 2, and 3, if this was crime scene, if this was a case I was working, these would be items that came in from the hospital, let's say, from the victim's body. Here I can put down testfire 1 as one known source and testfire 2 as a second independent known source. And this is from casework that you are currently working on. So you're the one who would have just test fired the gun for the first one, another gun for the second one. So you know the relationship of all these items because they're in front of you in your laboratory as you're working on the quantum system. Let's go ahead and hit OK to run the quantitative analysis on this. Actually, I can name this as I want to right now as well. We'll just call this QA01. We'll run that quantitative analysis. And let's resize the scoring here just to see the size of the charts a little better. So if you've not seen this before, there are two rebel graphs now that appear on the screen here, the RBL graph, or rebel graph as we call it. And the content of what is mapped out within that graph is from a combination of each comparison between item 1 and item 2 in the first two columns here, and how they are scored along the pattern matching score as well as the line counting score. And so their performance horizontally and vertically is going to map each one out within the rebel graph that is charted then diagonally to establish what the false match rate value would be. So if we look at our score columns down here, column 1 has fragment 1, column 2 has fragment 2. Pattern matching score here is a value of 0.59. The line counting score is 0.52, and that combines for a 9.96 FMR value. If I highlight that, I can see exactly which one that's charted out to. There's my 0.59 just below 6. There's my 5.2 just above the 5, and those combine together to give that particular comparison an FMR value of 9.96. And now the formula applied to that, if you don't recall, is 1/10 to the power of the FMR number. And so 1/10 to the power of 9.96, well, 1/10 to the power of 10, I believe, is 10 billion. So this is just under 10 billion, let's say 9 billion. That means that the false match rate is 1 in 9 billion. The odds of a different firearm producing more similar markings than this pair is 1 in 9 billion. And let's go ahead and double click on that and do a comparison between these two to see why that was such a high value. And now between these here, this is fragment 1 that only had that one land engraved area. Fragment 2 had the 3 that were acquired across, and the midpoint of that region here looks good against that first one. Let's add some 3D rendering. Let's play with that side light angle a bit. I like to get it a little bit flatter with a low incline. And let's line these up as well. So during that comparison work here, we can move these around, do that work, do the side light work to see what the agreement is. And sure enough, there's a lot of strong agreement between these two, which led to that strong score. At this point, I could do a screen grab if I wanted to. I could look at them in the shape view rather, but let's just get out of this for a second now. And let me close my email too, because that's doing no favors. And so that was, let's order it by the FMR value. So here, the chart on the left is working solely off of the best Lee-to-Lee comparison between the two items compared. So only one Lee on the reference exhibit, only one Lee on the test exhibit is being calculated for this performance. Here, it's using multiple in a phased alignment. So provided that the phasing agrees amongst the comparison itself, you'll have higher scores on this front. Because I know that fragment 1 that I just imaged moments ago essentially only has one land engraved area on it, I'm going to be looking at this graph a little bit more because there is no phased option for at least one exhibit in this 5 exhibit workspace that I'm working on. So that's why I'm concentrating a bit more on the left chart here than on the right chart. Now there's a big difference between these two charts here, and that is a second line that goes across diagonally here. That is your subclass warning coefficient line. And what that refers to is that when you have a score that is above this line here, but in this area, it's making you aware that yes, we're seeing agreement here, but you should be aware that it could be because of subclass that there is all this agreement. And items that do score in that range will be given a subclass warning coefficient score, and provided that score is below 0.8, then you should be pretty comfortable that it is a match on identifiable marks. If it's above that score of 0.8 or higher there, if it's 0.8 or higher, then you should be very concerned that what you're seeing is subclass. But you would be applying your skill set as a firearms examiner to what you see in that comparison when you're making your conclusions on what it is you're seeing. We're running out of time here, so let me show you one last thing that I want to get into. Screenshot before leaving, yes. So as I leave that quantitative analysis screen, I am memorizing the progress that I made. I can revisit this whenever I want to. Last thing I want to show you here is a way that I can use this comparison microscope portion of quantum in a way that the traditional comparison microscope never could. I'm going to select all of these. I'm going to get rid of fragment 3 though, and I'm going to also select testfire 2 and fragment 3 in that order. And now with testfire 1, fragment 2 selected, and then testfire 2 and fragment 3 selected, I can open up a comparison viewer here with all 5 of these items available to me for a comparison. If there was a 6th, I could also have a 6th here. You can have up to 6 items shared across the screen like we're seeing right now. So let me zoom into a better view here. One more. And let me add my 3D rendering. Play with the shadows as well. What I can do now, I just remember from previously that land impression 4 matched against 1 and 2 within this set. So I can do a comparison now across testfire 1, fragment 1, and fragment 2, where the machine made me aware of all the agreement that was happening there. And independently now, I can actually do some work here. Let me take fragment 3. I know that fragment 3 has a very well-marked feature here in the middle of that land engraved area. And from there, I can go and try to find that same feature. That's not it. Here we go. So I can, let's bring this down to about the same height as the other ones. And then if I lock this again, I can bring all of them up to about the middle of the screen here. I can set up an ongoing match between my first set of comparisons. Let's move this so that I can see the title of fragment 1 in it. I can have an ongoing match between the testfire fragment 1, fragment 2, and then introduce a gap here, and then also have testfire 2, fragment 3, all in one shot. And I can take a screenshot of that. I can call this comparison summary, let's say, and save that now as the overall comparison of this, everything in that workspace. And that's possible because there were 6 items or less in the overall comparison. I could have done that as testfire 1, frag 2, and then a separate screenshot of testfire 2, frag 3 as well. But there's all kinds of different ways that you can chart and map out the progress of your comparison using the quantum 3D microscope. And the quantitative analysis, of course, helps you understand the relationships of all the conventionally rifled items within that workspace. Let's jump ahead now and continue with the presentation here. Now you saw me do the screenshots there. And so the screenshot takes that picture in the workspace and lets you come back and revisit that to continue your progress in the comparison. But when it does that screenshot, it's not just giving you access to it in the workspace itself. If you go to where your workspaces are saved on your computer, you can access that the content of that particular workspace and go to the comparisons folder here. And inside that comparisons folder, you can find the PNG, the snapshot, the actual still image of the snapshot you took, the screenshot you took. And then that is available for you to do a copy and paste and bring that out of your quantum and put that into your lab notes, your casework notes to accompany the file and your findings on that comparison. So you're not just capturing the progress with those screenshots, you are also capturing the actual comparison as you had it, and those can be applied into your notes quite easily. So I went a little bit long there. Let me open this up now to questions. Michelle, I think you were tracking the questions as they're being written out throughout the presentation there. Are there any questions to address?
Now, there are no new questions. And by the way, I really appreciated seeing that summary snapshot. I'd never seen you do that. So kind of interesting to have that summary and you say that as a PNG. So yeah, thank you for that surprise this morning. There was one question about translation to Spanish. We have a lot of Spanish-speaking attendees, I believe, and we'll try to provide, like this is recorded and it'll be available on our website. You can go to the next slide, Andy. All our webinars are always put up on our webpage for the Quantum 3D Microscope, and we'll see what we can do. If there's enough interested attendees that would like to see this in Spanish, please let us know, and we'll work on that. And like it says here, like on the web page, you can search on our website. The link is there. You can copy it. And there's a lot of recordings from previous webinars. Like I mentioned at the beginning, there's a white paper, the benchmark study document is there, and other related documentation. If you have questions after this webinar, you can request that from us through the website, or it points to our general email for questions, and we'll be happy to answer those questions. And since we're running a bit long for time and there are no new questions for you, Andy, unless you have other things that you want to mention that you didn't present.
No, I mean, that's the main points are covered there that I wanted to showcase. Thank you very much for your time there, everyone. I appreciate that.
Yes, thank you very much, Andy. It was a very interesting presentation. And thank you, everyone, for attending today. We're happy to have you in good numbers. And we'll look forward to our next webinar. So everybody stay safe, and we'll see you soon.
Thank you.